The periodic table is an important document that summarizes a great deal of information about all of the known elements, and we'll be using this document throughout the course, and so it's very important for us to understand how to interpret the periodic table. So to introduce us to the periodic table, let's look at this simplified version. In this table, each element is represented by a 1 or 2 letter symbol. So hydrogen over here on the top left has the symbol of a capital H. Helium over here on the top right has a capital H and a lowercase e. And so each element has a unique 1 or 2 letter symbol. It's important to notice that in all cases, the first letter is always capitalized and the second letter is never capitalized. Now the number above each element, here above helium is the number 2, is what we call the atomic number. And this represents, as we will find, the number of protons within a single atom of each element. And the table is organized in order of increasing atomic numbers. So going from hydrogen at 1 and helium at 2, lithium at 3, beryllium at 4, and come down to uranium at 92. Uranium has 92 protons. Most of the elements are metals. So if we look along this bold line which divides our metals over on this side, all of the elements to the left of this diagonal line, with the exception of hydrogen, which is not a metal, of course, it's present as a gas generally. So most of these elements are metals, and we're familiar with the properties of metals, and many of these you are familiar with in your daily life. There is iron and copper and zinc and aluminum, and of course silver and gold, mercury, lead, right, even magnesium. These are all common examples of metals. And metals usually share common physical and chemical properties. So they tend to be solids at room temperature. They tend to be hard and shiny and malleable. And importantly, they tend to be good conductors of heat and electricity. In contrast, over on this side, we have our nonmetals. And the properties of nonmetals are very different from the properties of metals. So they tend, as solids, to be dull in appearance and brittle, and not at all malleable. And importantly, they tend to be poor conductors of heat and electricity. Or, in other words, they tend to be good insulators. So common examples of this are neon and argon and nitrogen and oxygen and fluorine, sulfur and phosphorus, etc. Now, at the interface between these two groups are a special class of elements that are intermediate in their properties between metals and nonmetals. And these are what we call the metalloids. And so they have properties that are neither metallic properties nor non-metallic properties. So they tend not to be good conductors of heat and electricity, but they also tend not to be good insulators. So, for example, silicon is the most common example of this, and we know that silicon is important for the electronics industry. That is, it's the basis of what we call semiconductors. That is, it's neither a good conductor nor a very poor conductor, and this has important implications for its uses in semiconductors that make all of these wonderful electronic devices possible, like your cell phones and your computers and things like this.